Okay, so we just discussed the fact that at the postsynaptic membrane, there are these new ion channels being opened when you have a specific receptor interacting with a specific transmitter to open a specific ion channel or set of channels. So again, there is this postsynaptic membrane. This membrane has both the passive channels and the synaptic channels. And these red synaptic channels enable current to flow either from the outside into the cell or from the inside of the cell outside. And this is why I will redraw what I started with for this section. I will redraw the full membrane circuit for the postsynaptic membrane. There will be the resting conductance, G rest, with its own resting battery. This will be our E rest. This is our minus 70 millivolts. So this is the passive circuit. This is the passive part of the circuit. Now I'm going into the synaptic part. So this will be the synaptic conductance and the associated battery. For example, a battery with a positive side into the cell, or it could be the opposite as we just discussed. So this is my synaptic path. This is my passive current path. And of course, everything else that is not ion channels, that does not allow the flow of current through the membrane, behaves like a capacitance. This is the outside, and this is the inside of the cell. And this is what we call the synaptic battery, E-synapse or ES. Okay? So this is a full circuit, and now you can realize that whenever I add into a given circuit, the passive circuit, another path for current flow, there will be probably voltage change. Just because you have a battery which is different than the resting battery. If this battery would have been exactly the same as the rest battery, then changing the conductance here will not make a difference, because this battery and this battery are the same. But typically they are not the same. For example, this battery is more positive inside than the resting battery. Then you can expect that if I open this conductance, because transmitter was interacting with the receptor and I opened this path, I would expect now positive current to flow inside the cell, and the cell will become more positive than before. Why? Let's write now the equation that describes this circuit as we did before. So what is the equation? This is now almost the same as before when I had passive membrane, but not exactly. Before, there was C dV dt as before. Also here, the current that is in this point may flow this direction and will become a capacitative current. That's as before. As before, we have now G rest is this conductance multiply by V minus E rest. This is exactly Ohm's law. What is written here exactly is that the current that flows here depends on the difference between the voltage V in one side of the resistor, of the conductance, to the other side of the conductance. So it's V minus ER. This is the voltage difference between the two sides of this conductance divided by R or multiplied by G. So this is the passive current. This is the passive current. This is the capacitative current. That's like before. But now you have a new current. This is a new current. This is the red current. The current that flows through new channels that are being opened. And it's exactly like the passive current, but in this case it's the synaptic current, G synapse, multiplied by the difference of voltage, V minus the synaptic battery, E synapse. Okay, so this is exactly V, the membrane voltage at this side, minus the synaptic battery at this side, divided by the resistance of the synapse, or multiplied by the conductance of the synapse. So this is the synaptic current. So you see that in this circuit you have three types of currents. The capacitative current, the passive current, or the resting current, and the synaptic current. The sum of these three must be zero. There is no extracellular, there is no external current going into this cell. I don't inject any current. I just open a new path. So at any given point here, according to Kirchhoff's law, the sum of this one plus this one should sum to zero. Okay? So this is the equation. Capacitative current plus passive current plus synaptic current equals zero. So I need to solve this equation in order to get this V, which is the voltage being generated by the synapse. By the fact that there is a synaptic conductance, there is a voltage change, and I'm interested in this voltage change. I want to know what is the change due to the opening of the conductance of the synapse that I will call the postsynaptic potential. So I really want to discuss with you the postsynaptic potential, the potential being developed at the postsynaptic membrane due to the activity of the synapse.